Okay, so I think we left off talking about that it's best to go through and put in your values for f of x and g of x before you compose f composed of g of x. So when you go through, you should put in all of your f of x values. So at -3 on f of x, go to -3, go to f of x, and we get -2. I'm going to go to -2 and I get 0. I'm going to go to -1 and I get 2. I'm going to go to 0 and I get 1. I'm going to go to 1, I get 0. Go to 2, I get 1. I'm going to go to 3 and I get 2. I'm going to go to 4 and I get 3. Okay, so now I'm going to do my g of x. So g of x, we were talking about, it's the other graph. Let me get my highlighter. So my g of x does, okay, so following g of x, we now have -4 was 2, -3 is 1, -2 is 0, -1 is -1, 0 is -2, 1 is very unique. So when I go to 1, what is it? Where's 1? It's like a -1/2, right? So -1.5. And then we're going to go to 2, and that gives us -1. We're going to go to 3, and that gives us -2. And we're going to go to 4, and that gives us -3. Okay? When you're composing, it's saying that G, so you're going to go to G first, and then whatever you get from G is going to take you to F. Since I have the tables filled in, I don't really have to look at the graph anymore. I'm just going to use the table. So for example, we did G of -4. So I'm going to go to G of -4. So I go to -4, I go to G, and we get 2. So now I'm going to go to F of 2. So I go to F of 2. I go to 2, go to F, and we get 1. Now we're going to do the rest. So we're doing f g of -3, we're doing f g of -2, then we have f g of -1, we have f g of 0, we have f g of 1, I'm squeezing it in there, guys, f g of 2, f g of 3, and then f of g of 4. Okay, so I'm going to go to -3 first and then go to G. So -3, G is 1. So I'm going to go to 1, then I'm going to go to x equals 1, go to f of x, and I get 0. So this is what you were supposed to do and finish. So checking yourself, these are the values you should end up with: 1, 0, 1, 2, and then 0. And then with the negative here at 1, so when we go to G of 1, so we're going to go to 1, and then go to G, and we get -1.5. Well, we don't have a -1.5 on here, so that means we have to go over here to look at -1.5. So when we go to -1.5, it's like halfway here. This is our f of -1.5. So f of -1.5 equals 1. Okay? So we go to 1, because that's what f of -1.5 would be. Does that make sense? Because we don't have it on here, so it would be 1. And then back to our regular scheduled program. Go to -1. -1 leads me to 2. So we have 2, 0, and -2. Okay, so now I'm going to graph my new created graph. And these are the values that I'm graphing for my y's. We have 1, 0, 1, 2, 0, 1, 2, 0, -2. So those are the points of the y values, and the x's are still the same. So at -4, 1, so I go to -4, go to 1. I have -3, 0, -3, 0. I have -2, 1, -2, 1. I have negative 1, 2, negative 1, 2. I have 0, 0. I have 1, 1. I have 2, 2. I have 3, 0. And I have 4, negative 2. And it looks something like, pretend that I went through all of those beautiful points. Okay? And that is composing from a graph, creating a table, and then creating a graph. All right, all skills that you are fully capable of doing. I believe in you. All right, on to the next. So now we have F composed of G, G composed of F, and the domain of F composed of G. Use a graphing utility to graph each composition and composition function and determine whether F is composed of G. So when we are graphing, we're going to see whether, if I actually could graph, I can't open the graph right now, but if you were to graph, you would be seeing if it's a reflection over the y equal x line. Okay, but since you can't, we're going to sneak ahead and do a little bit of algebra before the next unit. So algebraically, to prove that these are equal to each other, we're just going to do the math. So we're just going to see, it says prove or determine whether F composed of G equals G composed of F. So we're just going to solve both. So we're going to do F composed of G, which means that I'm going to have F composed of G of X, which equals F composed of the cube root of X plus 1. Okay, so we're going to evaluate that. So we're plugging in cube root of X plus 1 in for X. So the cube root of X plus 1 cubed minus 1. We keep going. When you cube a cube root, it quote unquote sets it free. So we're left with X plus 1 minus 1. And then here, X plus 1 minus 1 plus 1 minus 1 equals 0. So all we're left with is X. So F composed of G equals X. I should have drawn a line to keep myself in bounds. I don't know why it's so hard for me to draw a straight line, guys. All right, now we're going to do G composed of F. So G composed of F means that I'm going to do G with F of X, which equals G composed of X cubed minus 1. All right, so we're going to substitute that X in. So that leaves us with the cube root of X cubed minus 1 plus 1, all underneath the cube root. So again, here you have negative 1, positive 1. They're going to equal 0. So you're left with the cube root of X cubed. The cube root of X cubed equals X. So for this problem, F composed of G equals G composed of F, which equaled X. So yes, they're equal to each other. All right. Now we're going to do it on this side. So again, we're going to do G composed of F. Sorry, I didn't want to do that one first. We're going to start off with F composed of G, which equals, my hand is cramping and making me do weird things. Here we go. F composed of G of X, which equals F composed of 3x plus 3. Okay? Oh, I forgot to state the domain. The domain of just x is all real numbers, right? So I'm going to substitute this in. So we end up with 1/3 3x plus 3 minus 3. Okay, we're going to distribute. That's going to give us 1/3 times 3 is x. 1/3 times 3 is 1 minus 3. And that equals x minus 2. Okay, So f composed of g equals x minus 2. Okay, I think we're doing the right one. And now we're going to do, okay, so now we're going to do g composed of f, which equals g composed of f of x, which equals g composed of 1/3 x minus 3. So when I substitute that in, I end up with 3 times 1/3 x minus 3 plus 3, right? So again, we're going to distribute 3 times 1/3, 3 times negative 3, and we're left with x minus 9 plus 3. And x minus 9 plus 3 is going to give us x minus 6. Okay, so for one, we had x minus 2. For the other, we had x minus 6. So determining whether f composed of g, the conclusion here is f composed of g does not equal g composed of f. And this is going to be important in 2B.3 when we start talking about inverse functions, okay? So this is an example of when f composed of g equals g composed of f, your result is going to be x. And then if f composed of g doesn't equal g composed of f, then your results can be anything, as long as they're not equal to each other. All right. Excuse me for yawning. Next, we're going to look at our example that we have here. It says the volume V in cubic meters of a weather balloon is given as V of R equals 4/3 pi R cubed, which is just the volume of a cylinder. So if the radius R is increasing at a rate of R of t equals 1/2 t cubed, and t is greater than 0 seconds, find the volume V as a function of time t. Okay, so when we say function of time t, that means that I have to find r. And what does r equal? Well, r equals 1/2 t cubed. So V of r equals V of r of t, right? Does that make sense? V of r of t, because your radius depends on what time the deflating is happening. Not necessarily deflating, but you know, the time in seconds. So we have equals V of 1/2 t cubed. And it wants us to find what this means in terms of V of t. So ultimately, just getting it down to V of t. Okay, so now we are going to go through and simplify. So when I substitute this in for V, I'm plugging in for R 1/2 t cubed. So we have 4/3 parenthesis, 4 pi thirds parenthesis 1/2 t cubed is my whole entire input to the third power. Okay, remember when you have a power outside of parentheses, that power is going to apply to each factor inside of the parentheses. So you're going to have 1/2 to the third. So we have 4 pi thirds, and you're going to distribute the 1/2. 1/2 to the third is going to be 1/8, and then you're going to distribute it to the 3. So we end up with t to the 9th, because 3 times 3 is 9. So this is where we're at, and we're going to keep simplifying, cleaning this up. A quick little simplifying is that notice I have a 4 in the numerator and an 8 in the denominator. They can simplify. 4 divided by 4 is 1. 8 divided by 4 is 2. So I simplified before. Now I'm going to keep going. So I have pi times 1 is just pi. 3 times 2 is 6, and I'm left with t to the 9th. So here is V of t in terms of time. So a V of t equals pi over 6 t to the 9th, and this is in our volume in meters, so cubic meters. And that's the formula I would use. So if I'm going to say, okay, what's the volume at 3 seconds? Well, I'm going to plug in 3. What's the volume at 10 seconds? Now I'm going to plug in 10. But it's now in terms of volume instead of in terms of the radius. Okay, so that's using composition. And then the last one here we have is a bacteria problem. The number of N of bacteria in a container of a leftover food stored in a refrigerator, where T is the temperature of food in degrees Celsius, can be modeled by N of T equals 60T squared minus 140T plus 76. When the container is removed from the refrigerator, the temperature is T of T equals 5T plus 3, or T is between 0 and 3, or T is a time in hours, so between 0 and 3 hours. Okay, so the first thing it says is find the composite of N of T and explain its meaning in context of the scenario. Okay, so if we are going to have the number of bacteria given, is it temperature? T for temperature? Yeah, temperature at time T. Right? So I'm going to substitute that in. So N T of T, so T of T is 5T plus 3, so 5T plus 3, which equals, and we're going to substitute that in for T. So we have 60 times 5T plus 3 squared minus 140 times 5T plus 3 plus 76. Okay? Through a series of multiple distribution and combining of like terms, we're going to come down to 1,500 T squared plus 1,100 T plus 196. And that's going to be our N of T. So this is going to be the number of bacteria that will be left over. Number of bacteria present, yeah. Present in the leftovers. I know it doesn't sound like, ew, Miss Jones. Leftovers when sitting outside from 0 to 3 hours. Okay, I should have probably wrote 0 to 3 hours, but I did not. When T is between 0 to 3 in hours. Okay, so it says now, can I use this to find the number of bacteria present in the food after the container has been sitting out of refrigeration for 2 hours? Yeah, so I'm looking for N of T. So N, and my T is 2, so N of 2 equals 1,500 times 2 squared plus 1,100 times 2 plus 196. I'm going to plug that in the calculator, and I get 8,396 bacteria present after 2 hours. After 2 hours. Okay. I also, if I need to find out the temperature, so if I need to find the temperature that took place here, I could also find T of T. So I could find, just a side note, if I need to find temperature, it would just be 2T of 2, which equals, and that would be 5 times 2 plus 3. So the temperature is 13 degrees Celsius after 2 hours. After 2 hours, which resulted in the 8,396 bacteria present. Okay, all right, that's it.